Section 3.4, example 1, performing algebraic operations on functions. So find and simplify the functions f minus g of x and g divided by f of x, given these two functions. So we're given a function for f and we're given a function for g. Are they the same function? Guessing that's a question mark. Okay, so let's get started with this first one. Let's first find f minus or g minus f of x. So g minus f of x. So we're writing it just the way that we see it spelled. We're looking at the function g of x. Our operation is going to be minus and f of x there to follow. So we got g of x minus f of x. So the first function, the action, and the second function. So here, g of x, we have the function here. So we'll put that in brackets. You can use brackets or parentheses. Those are interchangeable. They're just like placeholders for that separation. And next we have the action minus, and then our second function, f of x. F of x is our x minus 1. Now that we have that, we do have an action over here. We don't have anything that we're multiplying into this function, so we could jump straight to this one over here. And it looks like we're multiplying this negative to each of the terms outside of that function. So here we could drop the brackets, x squared minus 1. Here we're multiplying that negative 1 to that first term, so minus x. And we're multiplying this negative to that second term. Negative times negative is a positive, so that's going to be plus 1. From here, we could combine like terms. We have an x squared here, so we can't really combine it with anything else because we don't have any other x squareds here. So we could just write that part in. Next, let's go down in degrees. So this is x to the power 2. Now we're going to look for all the x to the powered 1s or just x's. And I only see one of them right here. So we're going to write that one. There's a negative in front of it. So we have minus x. And next we have our constants, the ones with no variable. So here we have a minus 1 and a plus 1. -1 plus 1 is going to be 0. So we could do a plus 0 here, but there's no use in doing that. We could just write it like this. So x squared minus x. And there's that first one. Now let's work on the second one. G divided by f of x. So g divided by f of x. And here we're looking at the function g of x. The action here is going to be to divide, and we're dividing f of x. So the way that we could state this is g of x divided by f of x. And here we write our function g of x. So our x squared minus 1. Our action here is to divide. And we're dividing that second function, f of x. F of x is our x minus 1. And now we have these two binomials that we could factor. It looks like we could factor this numerator up here. That's the difference of squares. So if you guys don't remember what the difference of squares is, we have a squared minus b squared. We could factor that to be a plus b and a minus b. So here, x squared, the square root of x squared is going to be x. And the square root of 1 is just 1. Over here, it tells us to put a plus in the middle of one of them, a minus in the middle of the other one. So we're going to do that over here. And there we go, fully factored. We're dividing all of this by x minus 1. And I'm so glad that we did that, because at this point, it looks like we could divide those two out. So dividing those two out, we're left with just an x plus 1. So for this one, we could state this one as g of f of x is equal to x plus 1. That's our final solution here. Just like the final solution up here is going to be g minus f of x is equal to x squared minus x. Now their question is, are they the same function? Definitely not. So not the same function. Here we're subtracting two of the functions. Over here we're dividing two of the functions. So it doesn't look like we would have any sort of similarities. If we did have a similarity, it would just be by coincidence. It wouldn't be because they hold some special power or anything. Let's move this down a little bit just so it doesn't look too jumbled. And there we go. If you have any questions, please feel free to ask. Otherwise, bye.